All right. This is a exam review stamp sheet for Montgomery County MCPS Semester 1 Pre-Calculus Exam Review. All right, so this is the solutions, and we're going to cover video problems 32 through 39 in this video. All right, so let's get started. All right, problem number 32 says determine the equation that best describes a sine curve with amplitude 3, period of 6, and a phase shift of pi over 2 to the right. All right, so we're looking at making that equation y is equal to a sine b x minus c plus d. All right, in this equation they tell us the amplitude is 3, so a is 3. All right, they tell us the period is 6, and to find b, we go b is equal to 2 pi over the period. All right, and so b is going to be 2 pi over 6, which is pi over 3. There is a phase shift, right? Pi over 2. So that's letting us know that c is equal to pi over 2. All right, but when we put it in the equation, it's the opposite, and there isn't a vertical shift. All right, so our equation for this should be y is equal to 3 sine pi over 2 times x minus pi over 2. All right, and I felt like I did something wrong, and I did. This should be pi over 3, sorry. Not a good way to start off the videos. All right, welcome. In this exam review stamp sheet, we are looking at problems 32 to 39. All right, and let's get started. All right, problem number 32 says, determine the equation that best describes a sine curve with amplitude 3, period of 6, and a phase shift of pi over 2 to the right. All right, so we're trying to write that equation, and y is equal to a sine b times x minus c plus d. All right, this gives us our amplitude. All right, we're going to find our b by going b is equal to 2 pi over the period. All right, our c is our left-right shift. All right, and d is our up-down shift, our vertical shift. So they tell us that the amplitude is 3. Period is 6, and the phase shift is right pi over 2. All right, so amplitude is 3, that's pretty simple. All right, so we got y is equal to 3 sine. All right, b, we need to get the b value, so we're going to take our period, we're going to go 2 pi over 6, which is pi over 3. All right, so that gives us our pi over 3 times x. Now notice that this is minus c, and it's telling us right c, so c is equal to pi over 2, but when we put it in the equation it's minus pi over 2. All right, and there isn't a vertical shift, so we are done. All right, number 33. For each equation below, state the amplitude, the period, phase shift, vertical translation, and any reflections of the sinusoid relative to the basic functions. F of x is equal to sine x, or g of x is equal to cosine x. So we're pretty much doing the opposite of what we did in the previous problem. All right, and let me write this as 33, a little bit bigger. All right, so for the first problem, h of x is equal to 2 sine 3x minus pi over 6 plus 5. All right, and we just want to pull our A, B, C, and D out. All right, there isn't a reflection because this is positive. All right, our amplitude is 2. All right, our B value, all right, is 3. All right, and we want to change that to period. So we say period is equal to 2 pi over B. All right, and so that's going to be 2 pi over 3. All right, our C value is pi over 6. All right, and that lets us know that we have a shift to the right, pi over 6. All right, and our D value is 5, and so that lets us know that we are shifting up 5 units. Okay. All right, and so that's what we want to do with the other problems. All right, so let's keep it going. All right, B, problem B, it's h of x is equal to negative, so that's going to be a reflection. Cosine, you got pi times x plus 1. All right, so in this case, all right, A is equal to -5, but the amplitude is always positive, so the amplitude is 5, and it's also reflected about the x-axis. All right, B, well, B is equal to pi, which means that the period is 2 pi over pi. All right, and that's equal to 2. All right, C is equal to -1, and that lets me know that I am going to shift left. All right, remember when we pull it out here, it's always the opposite. Left 1 unit. All right, and then finally the last one, which there is a little extra work to be done for the last one. All right, so let's see. C, you got h of x is equal to sine. It's really not in the form that we're used to. All right, where the b is outside of the parentheses. Right now, there's a coefficient with the x, and so we want to just divide this by 4. Just factor out a 4. All right, so we're going to rewrite this as h of x is equal to sine 4 times x, and if I divide this by 4, this gives you minus pi over 4 minus 2. All right, now that's a better form for us, and I'm just going to erase that right there. All right, I actually didn't divide, I just factored it out. All right, so it was still there. So if I multiply this back, I still would get what's right there. All right, so now that I have that, well, my amplitude is 1, so no change. All right, my B value is 4. All right, which means that my period is going to be 2 pi over 4, which is pi over 2. All right, I shift, and this is where students would get it wrong. They might say I'm going to shift to the right pi if they look at the original equation. But if you pull the B value out, you'll see that you're shifting to the right pi over 4, and you are shifting down 2. All right, with problems number 34, you need your exam review sheet. You might need some of your trig identities to determine which identity you're using in order to simplify this. So I see 2 sine 17 degrees, cosine 17 degrees, and it reminds me of the double angle sine where that's theta. So if I do that, and I think I'm just going to write right on, well, I don't think we can see that well. Alright, I'll do it down here. 2 sine 17 degrees, cosine 17 degrees. Alright, translates using sine 2 times 17 degrees, which means that this is sine 34 degrees. Alright, keep going. A, that's alright. B, we have cos cos. Alright, if you're in my class, you know, you've heard me say cos is cos cos. Alright, so we're dealing with a sum or difference identity using cosine. Alright, I probably get it faster than I can write this. Alright, so in this case, cos cos, it's cos is cos cos, so this is going to be cosine. Alright, and the sign is always opposite, so we're looking at this one right here, but it has a minus. So if you read your formula sheet, the minus is on top, and that means that the plus is on top in the cosine. So we're adding here. Alright, and so this becomes pi over 7 plus 3 pi over 7. Alright, and all they want you to write is that this is equal to cosine 4 pi over 7. Alright, C. I'm going to change pens if I can't find it. Alright, C. Alright, we have sine 7 cosine 3 minus cosine 7 sine 3. Alright, and in that case it's a sine because it's not cos cos. Alright, they aren't together. So this is sine something, 7, 3. And in my class we say if it's a sine, then it's sine, same sign. Alright, and so this becomes sine 4. Alright, keep it going. D. Alright, D, we have tan 11 plus tan 25 over 1 minus tan 11 tan 25. Alright, so looking at that one, that's definitely tan. It is tan, and we look at the numerator to decide whether it's sum or difference, and it's sum. So this just becomes tan 11 plus 25. Alright, and that is tan 36 degrees. Alright, keep it going. E. E, 1 minus 2 sine pi over 9 squared. Alright, and I'm looking for some 1 minus. I'm doing the same thing that you do. So I'm just trying to see which one fits, and it's this one right here. Alright, and so that's that double cosine. Alright, and so what we want to say is that we have cosine 2 times pi over 9. Alright, and that's going to give me cosine 2 pi over 9. Alright, keep it going. F. Cos cos again. Cos 8. Cos 5 plus sine 8 sine 5. Alright, and so it's cos. Alright, different signs though, so we're going to go 8 minus 5, and that's going to give us cosine 3. Alright, G. G, we have the square root of 1 plus cosine 23 degrees over 2, which leads me to believe this is a half angle. but let's see which half angle it is. All right, if it was a minus here, it would be sine, but there's a plus. All right, and so it's that one. All right, and the angle is 23 degrees, so we go cosine 23 over 2. We're done with that one. And then the last one, h. All right, you got sine 7 pi over 13, cosine 5 pi over 13, plus cosine 7 pi over 13, sine 5 pi over 13. All right, and it's not a cos, it's a sine cosine, so it is sine. All right, same sign, so we want to go 7 pi over 13 plus 5 pi over 13. All right, and that's going to give us, can you see that? Sine 12 pi over 13. All right, 35, they give us a little bit of information here. They tell us what quadrant we're dealing with, and that anytime it's 0 is less than a, which is less than pi over 2. We know we're dealing in the first quadrant. I tend to make a triangle, first quadrant triangle. Remember, when we make our triangles, we always use which axis, guys? The x-axis. All right, drawing our right triangle. All right, this is all no calculator stuff. You notice we're not pulling out a calculator for any of this. Now, they give us cotangent. They tell us that cotangent A is equal to 12 over 5. Now, cotangent, if tangent, and you can think of it this way, if tangent is opposite over adjacent, then cotangent is adjacent 12 over opposite, and then we have a 5, 12, 13 triangle. It's good to know your Pythagoras triples, at least a few of them. 3, 4, 5, 5, 12, 13 are the ones that are used the most. All right, now that I have that, I can go back through and get some other values. Now they're asking me for a double angle, which means I need sine and cosine for double angle. All right, for cosine, I need cosine double angle. I need sine and cosine. All right, for this I need cosine, and for cosine A over 2, I need cosine. So let me find sine A. All right, sine A is going to be 5 over 13. All right, and cosine A is going to be 12 over 13. So I got to start with those. All right, then I can do the problems. All right, ready to knock out these problems. Let's see. Change color again. These things are getting dull. All right, A, we're finding sine 2A. So sine 2A is going to be 2 sine A cosine A. All right, and so we're going to go 2, what is sine A? 5/13. All right, and cosine A is 12/13. All right, now I always take this 2 and make it 2 over 1, so I make sure I don't multiply incorrectly. All right, 5 times 12 is 60, times 2 is 120. All right, and 1 times 13 is 169. I'm done. All right, there's your sine 2A. All right, your cosine 2A. All right, and if you remember, if you're in my class, you can use any of these three. There's 1, there's 2, there's 3. I usually use that first one. So the first one says cosine A squared minus sine A squared. All right, and so we're going to put that cosine, which is 12/13, square it, minus 5/13, and square that. All right, that'll give us our answer. Let's see, that's 144 over 169 minus 25 over 169. All right, and subtracting that would give you what, 119 over 169. All right. Let's keep it going. Sine A over 2. All right, sine A over 2 is equal to the, well, we're first quadrant, so we're positive. All right, 1 minus cosine A all over 2. All right, I know what cosine A is equal to. It's 12 over 13. So I'm just going to square root of 1 minus 12 over 13 all over 2. All right, and with that, this is 13 over 13 minus 12 over 13 all over 2. All right, and so that's going to give me, what is that? 1/13 all over 2. All right, which is equal to the square root of 1 over 26. And that's fine. If you want to, if I were you, I'd take that and get the decimal value in three decimal places. I'm not going to do that for you. You can go ahead and do that. All right. Cosine A over 2. All right, and it's almost the same problem, but it's the square root of 1 plus cosine A over 2. So we should be able to do this a little bit quicker. All right, we are the square root of 1 plus 12 over 13 all over 2, which is the square root of, I'm just going to call that 13 over 13 plus 12 over 13 all over 2. All right, and that's going to give us the square root of 25 over 13 all over 2, which is equal to the square root of 25 over 26. All right, and I would leave it at, well, I guess you could make it 5 over the square root of 26, but that wouldn't be kosher. You need 5 square root of 26 over 26. All right, would be a better answer. Just like this one, I guess a better answer would be the square root of 26 over 26 would be a better answer if you're looking for an exact answer. And they don't say exact answer, which means that your answer could be to 3 decimal places. All right? All right, for problems 36 and 37, you might need your unit circle. It would help. I would advise you to, before you start the final exam, to just make a unit circle or take a scratch sheet of paper and make a unit circle. Do all your radians, your degrees, your cosine values, your sine values, and your tangent values if you know your tangent values. All right, that'll help you with that. All right, so in this case it says solve the following equation over the interval from 0 to 360 degrees, which means that they want their answer in degrees. They want the answer in degrees, so let's give it to them. All right, first problem, and we've done this. All right, we have 2 sine theta plus the square root of 2 equals 0. All right, we're solving for theta. All right, we want to subtract root 2 from both sides. All right, that gives us 2 sine theta is equal to negative root 2. Divide both sides by 2. That gives us sine theta is equal to negative root 2 over 2. If you look at your unit circle, hopefully you have one near you. Hopefully you have one when you close your eyes. That would be great. All right. But we're looking for values where sine is equal to negative root 2 over 2. All right, and that's going to be here. All right, and here. All right, and that those two values are 225 and 315. All right, for the next problem, we have 3 cosine theta plus 4 is equal to 5 cosine theta plus 5. We treat this just like any other algebraic problem. I would subtract 3 cosine theta from both sides. All right, that would give me 4 equals 2 cosine theta plus 5. Subtract 5 from both sides. That's going to give me negative 1 is equal to 2 cosine theta. Divide both sides by 2. Alright, that's saying that cosine theta is equal to negative 1/2. So this is where you go back to your unit circle, alright, and figure out where cosine theta would be equal to negative 1/2. Alright, we're going to go here, alright, at 120. You can look at your unit circle, alright, and here at 240. Alright, so theta is equal to 120, 120 degrees, and 240 degrees. Alright. Alright, number 37. Might as well keep going on the sheet. Number 37. Find the following in radians. Alright, so we have tan x plus 1 is equal to 0. We're going to subtract 1 from both sides. We have tan x is equal to negative 1. Now, where's tan x equal to negative 1? All right, should be at some of the negative diagonals for tangent. All right, and that would be in the second quadrant. All right, and in the fourth quadrant. All right, that's 315. All right, and this is what, 135? All right, any questions? No questions. I like it like that. All right, x is equal to 135 and 315. All right, looking at the next problem. This is one that got some people on the test. All right, we have 2 sine x squared minus 3 sine x plus 1 is equal to 0. All right, and we start this problem by just kind of getting rid of our sign. All right, we're going to put our sign back in the end. All right, and so we treat this as if it was 2 x squared minus 3x plus 1 is equal to 0. Now, if you do that, then you're solving. You can use quadratic formula. If you remember it, x is equal to negative b plus or minus the square root of b squared minus 4ac, all that. Or you can try to factor it, all right? I'm going to factor it the way that I show my Algebra 2 students. All right, we're looking for two numbers to give us a product of these two numbers, so a product of 2 and a sum of the middle term, middle coefficient, negative 3. Those two numbers would be negative 1 times negative 2. All right, and you're welcome to go back and rewind this as many times as you need to. All right, that gives us 2x squared minus x minus 1x. All right, because we just found our two numbers. All right, and we split our middle term using those two numbers. All right, and then I am going to do GCF grouping. All right, so I have a common factor of x. That leaves me with a 2x minus 1. Here I have a negative 1, and that would leave me with a 2x minus 1 equals 0. All right, now if we do this correct, these two are the same and we write them once. All right, and we write everything outside of the parentheses in the parentheses, x minus 1. All right, and so we factor. All right, now that we factored this, I can throw, well, we can finish solving. Let's finish solving first. X minus 1 is equal to 0, or 2x minus 1 is equal to 0. All right, and this is x is equal to 1, or adding 1, 2x is equal to 1, x is equal to 1/2. All right, now, what we're saying is that now we got to go back, we got to remember, well, it's not all algebra, we got to go back and put this sign in here. So we're looking for sine x, where sine x is equal to 1, and we're also looking for looking to see when sine x is equal to 1/2. All right, so those are your solutions. Let's see where they are on here. All right, that's 1. Look at your unit circle. That's one of your answers. All right, and that's at, well, what were they axis? Pi. So that's pi over 2. All right, that's for that one. All right, and then 1/2. Look to see where it's 1/2. Well, cosine is 1, 2, 3. So it's 1 here for sine. That's at pi over 6. Look at your unit circle, guys. All right, and also at the other over 6, which is 5 pi over 6. All right, so for this problem, my answers are x is equal to pi over 6, pi over 2, and 5 pi over 6. All right, number 38 takes us back to the first couple of days of school in August. All right, so I know it was a while ago. You had 2 formulas, and they are on the front of your formula sheet. All right, it's S is equal to R theta. All right, and S stands for arc length. All right, and we use that when theta is in radians. All right, and S is equal to theta over 360 times 2 pi r. That's the one that they give you on the paper. Theta is equal, theta is in degrees when we use that. All right, now that's a little different from the one that we use and the one that's in the textbook, but that's the one they give you on the formula sheet, so we might as well use that one now. All right, we have 3 problems here. One, it gives you radius. All right, tells you that the radius is 6. All right, so let's just erase this. All right, R is 6, theta in radians. All right, so they give you almost everything in radians. So we're using this formula for this problem. All right, it's pi over 4. All right, and they're asking for S. All right, so S is equal to, well, R, 6, times theta in radians, pi over 4. So that's going to be 6 pi over 4, which is equal to 3 pi over 2. And if you want to get that answer, you're going to go 3 times pi divided by 2. All right, and that gives you 4.7134. Remember, well, actually 7.3. All right, inches. All right, first problem done. Second problem, they give you R. They tell you R is equal, oh, I'm sorry. They don't give you R. R is missing. All right, theta is equal to 5 pi over 6. All right, and the arc length, S, is equal to 15 pi feet. All right, so let's go on. All right, so we once again, we're looking for R, and in this case, S is equal to R theta. So we can go 15 pi is equal to R, we don't know, times 5 pi over 6. All right. And we're just solving for r. So I might multiply, I think I would multiply both sides by 6. All right, that would give me 90 pi over here is equal to r times 5 pi. All right, divide both sides by 5 pi. All right, 90 divided by 5, just make sure, is 18. All right, and r would be equal to 18 what? R would be equal to 18 feet. All right, because we started with feet. All right, and the last one on the sheet, you have a radius of 10 meters, and you don't know theta in radians, all right, but you do know that the arc length is 30 meters. All right, so if that's the case, all right, we got, let's go ahead and write the formula again. S is equal to r theta. All right, so that's 30 is equal to 10 theta. Well, hey, we want to solve for theta. Divide both sides by 10. And so theta is going to be equal to 3. All right, and that's 3 radians. Everything's in radians in this case, and we're done. All right, for number 39, we're proving identities. And I know a lot of you, we spent quite a bit of time on this semester. Hopefully, we're pretty proficient at it. We're just going to jump right in. You should have your formula sheet somewhere near. All right, you may need it. All right, but let's go. All right, 39a. All right, we got sine theta, cotangent theta is equal to cosine theta. All right, remember I want to leave the right side alone and work with the left. All right, so sine theta stays the same. Cotangent is cosine theta over sine theta. All right, and we should notice that what happens? My sines cancel. I'm left with cosine theta is equal to cosine theta. Done. All right. B. Looking for a pen. All right. So B. All right. We have sine x plus cosine x all together square is equal to 1 plus sine 2x. So it's kind of tricky. You see the sine 2x, it's going to draw me to this identity. All right, I might need to use that identity in some type of way. All right, but first things first, this is sine x plus cosine x. It's squared, right? So it's sine, we are going to do that first. All right. Now, from here, I am foiling. First, outer, inner, last. All right, that's going to give me sine x squared first. Outer is going to give me sine x cosine x. Inner is going to give me a sine x cosine x. And last is going to give me a cosine x squared. All right. Now, I see sine x squared, cosine x squared. That's Pythagorean identity. All right. So I'm going to bring that together first. Squared x plus cosine squared x. All right. And I have two of the same thing. So I have two of those. 2 sine x cosine x. Now remember, I'm trying to get to this thing to the right, and I'm almost there. All right, this gives me 1, and this right here is the double angle identity. So that is sine 2x, and I'm done. All right, next problem. C. We have cosecant x over 1 plus cotangent squared x. I see that, and it makes me think, I hope it makes you look at the Pythagorean identities, at least that denominator part. All right, it's all equal to sine x, so hopefully we can get all this together. I don't think this one's that bad. All right, let's see. 1 plus cotangent is cosecant. So you got cosecant x over cosecant squared x. All right, now that means this is like saying I have cosecant x over cosecant x, cosecant x. So I cancel that, and so if I cancel, I have 1 over cosecant x. And the reciprocal identity, which is not on this page, but you should know what cosecant goes with, that is just sine x. And sine x is equal to sine x, and we're done. And I hope I have all that on there. Yeah. All right. Keep it going. Smudges. D is sine theta over cosine theta plus cosine theta over sine theta. Makes me think I'm gonna is equal to secant theta cosecant theta. Alright, so first things first, I need to get this plus out of there. I need to bring these two things together. I'm going to multiply this one by cosine theta over cosine theta. And I'm going to multiply this one by sine theta over sine theta. Now, the reason why I do that is because I need like denominators. Alright, so if I do that, this is sine squared theta over sine theta cosine theta. Alright, and this one is cosine squared theta over sine theta cosine theta. Alright, and now I can bring them together. That's sine squared theta plus cosine squared theta, which means we're going to use Pythagorean identity to get, you guessed it, 1. And the numerator, 1 over sine theta cosine theta. Now, 1 over sine theta is equal to cosecant. 1 over sine is cosecant, and 1 over cosine is secant. And that's what that is equal to, secant cosecant. Alright, keep it going. Alright, E is sine x plus y plus sine x minus y is equal to 2 sine x cosine y, which still looks like, yep, again, they keep using it, double angle sine. Alright, so this is a long problem, but it's doable. We're going to use our sum and difference sign to spread this all out. All right, so it'll look like this. This part right here, sine, same sign, so we're gonna go sine x cosine y plus cosine x sine y. All right, that's using this. All right, then I'm gonna use it again, but I'm gonna use the minus one, and the minus is minus. All right, same signs. So this part right here becomes sine x cosine y minus cosine x sine y. All right, now look at it closely and you will see that this cancels with this. All right, they cancel. All right, that leaves us with sine x cosine y plus sine x cosine y, which is equal to 2 sine x cosine y. Oh, we're done. Oh, nice. All right, F, last one. All right, let's hope I can keep doing this without making mistakes. All right, sine squared theta plus sine theta square plus sine theta square tangent theta square is equal to tangent theta square. Alright, so let's see what we can do with this one. Alright, I'm looking here and I see that there's a sign in both terms, so I'm going to factor that out. Why? I don't know, it just looks like the right thing to do. Alright, sine theta square out, so it's the opposite of distributive property, factoring it out, that leaves me with a 1 plus, if I factor out this sign, I have a tangent squared theta. Alright, want to get to something that looked familiar. Alright, and in that case I have 1 plus tangent theta square, which is equal to, look at your Pythagorean identities. Alright, that's secant theta square. Alright, so got that going for us. Alright, what is secant but 1 over what? Cosine. Alright. Theta. Hey, I'm going to write that over 1. Alright, that leaves us with sine theta square over cosine theta square, which is equal to tangent theta square. So it all worked out. Alright, and we are done.